Chapter 11, Inheritance and Polymorphism, back at it. Without any further ado, let's jump back over to the code we ended up with last time. And as a disclaimer, if you did not code that ending sample up that we're going to show you here, you need to just stop this video, go back, watch that previous video, and code it up, because this is our starting point. And you will need to have A, have this coded, and B, need to be making any changes to this code that we will be making during this video. So here's what we ended with last time. We had 5 classes. The first was this demo class where I created an object of type person, of type student, of type employee, and then we printed those objects. I then want to show you briefly the person and the address class here. The person class had 6 data members. One of those data members was a reference to an object of type address, which is then constructed, of course, when we're making that person constructor. So let's jump first to the address class itself. Here's the address class. We have 5 data members. We have 2 constructors. Of course, one of the constructors saves those 5 data members that are sent over as parameters. It saves them into their respective data members. We have the getters and setters, and then we have an overridden toString method, which we'll talk about as well. This is the person class. The person class has 6 data members. As mentioned, one of them is really this variable A, which is going to be a reference variable pointing to a new address object, which we created here in the default noarg person constructor. We're calling the constructor the default noarg constructor of address. Or if I make a new person by sending over 10 parameters, 10 formal parameters that are being saved there, the first 5 are saved into their respective data members, and the other 5 are forwarded on to create a new address object. Here's all the getters and setters. And then finally, we have an overridden toString method. What did that mean, overriding? So as we also saw last time, that every single class, every single blueprint, if it does not explicitly state that it is extending from some other blueprint, it will implicitly and automatically extend from object. So for example, when I come all the way up to the top here, I have public class person. You may recall I chose to explicitly type this extends object. I don't need to do that, because since I don't have anything after the word person, Java will automatically extend from or inherit from the object class. Now, if I had said extends some other class, then this person class would be extending from this class, and Java would not automatically extend this person class or inherit from the object class. But with nothing being written here, Java automatically inherits from object, or automatically extends object. Now, by virtue of extending object, as we learned, is this person class will inherit all accessible data members and all accessible methods of the object class. Well, what are those methods? Well, if you want to see them, I could type object x equals new object, and then simply type x dot. And now we can see a list of these methods. It's not many, but x dot, and we see a list of methods that belong to object that Java has built in for you. One of those methods is toString. And what does that toString method actually print? If I type x dot toString, what does it print? Is it simply prints a string representation of this given object. Now in this case, a string representation of this particular object, well, it's just the word object followed by an @ sign followed by this hash code. And so if you just want to type this in fact, type x dot, click toString, and you will see that returns a string representation of this object, and they go through and they tell you what it actually returns. It returns the class name plus an @ sign and plus a toString representation of hash code, and you can go read more about what that is. But the takeaway is this string representation is not the most helpful. The other thing we covered is that you don't even need to explicitly type toString, because it's very common to want to have a string representation of your object. Java just allows you to print your object by printing the reference variable, and Java will automatically invoke that toString for you. If you notice when I run this, those 2 lines of code generate the exact same output, because by merely typing X, it's the same as if you had typed toString, because Java does that for you. That was the other takeaway. Well, what happens here is when we typed person extends object, again, we don't need to type that, but we chose to because we want to feel the inheritance that's happening. When we type extends object, what happens? Well, this person class has now inherited the trash toString method. Sorry for calling it trash, but the trash toString method from the parent class, from object. Therefore, if I get rid of this, notice I just deleted what we had there. I can still, over here in my main, I can still print out the toString. Here I explicitly put the toString, but I don't need to. I can still print the toString of person, of student, and of employee, and this is what I get. I made a person object with all of these cool data members, with all of these cool parameters. But when I print that person object, what does it print? It prints the name of the class, an @, and an effectively useless hash code for our purposes. That's not very helpful. So what we chose to do is we chose to say, you know what, thank you so much, object class, for letting me inherit from you, right? Because we chose to type extends object, which we didn't need to, but we did. We could have just, again, left it blank. I know I'm repeating, but I want to make sure it's very clear. It automatically extends from object if you don't extend anything else. So this is the same thing as typing extends object. So we've extended from our object class. We've inherited from object, but we don't like that toString method. It's a pretty trashy, it's a garbage toString method. Sorry, parent object. And instead we say, you know what? Let's make our own toString, which was overriding. Overriding is we've inherited a particular method from our parent class, our superclass, but we say, you know what? Yeah, I think I can do a better job. I think I can make a better version of this same method. Thank you, parent, but yeah, no thank you. I'm going to make my own version. So we're effectively taking that parent method and that we inherited, and we're casting it to the side, and we're going to make our own version. That's what we did here. We took that inherited toString method, we threw it to the side, and we made our own version of a toString method. Now, when I erase this, as you recall, what happens is NetBean gives you an alert. It says, hey, add this override annotation. All it does is it serves as a reminder to you, to the developer, that this particular method is overriding a parent toString method that was inherited, but now we're overriding or overruling that method and we're making our own. That's what we ended with last time. When I run the code, here we now get different output. You do notice that the output for Carol Danvers, who is just a person, is the same as the output as Black Widow, who was a student, and is the same as the output for Steve Rogers, which is an employee. You notice that we did not actually print the additional student details, because the difference is that this student object that we also made last time, this student object had 2 student-specific data members, and the employee object had 2 employee-specific data members. We did not actually print those, and we'll talk about why, because we didn't really finish those toString methods last time. The specific toString methods for student and employee. We did not make them. We'll do that today. So here in the student class, what did we do? Well, when I called the student constructor, I sent over not 10, but 12 parameters. 10 of them were specific to every vanilla person object, but the final 2 parameters right here were the hours earned towards degree completion, as well as the GPA. And then the two additional parameters used for the employee object were their title as well as their salary. So when I come back and I come to the student class, we look at the constructor and we have 12 formal parameters. The final two are going to be saved into their respective data members. But what did we do with the first 10 parameters? Where we ended last time, as I simply stated, that those first 10 parameters, what we're doing here on this line of code is we are calling our parent constructor, who is person. I'm going to pause that thought and we'll come back to it in a bit. And now let's come back here to the slides. Let's talk about the overriding of methods in this superclass. An instance method can be overridden only if it is accessible. So a private method, if our parent class that we are inheriting from, if it has a private method, we're not inheriting that private method because it's not accessible. Therefore, there's no overriding to occur. If our parent class has a method called Bob, I don't know where that came from, and that method Bob is private, well, I will not be able to inherit that method. So if I make a method called Bob, that's not overriding because I never inherited that parent method Bob in the first place. What about overriding and static methods? So like an instance method, a static method can be inherited. However, a static method cannot be overridden. It's a small nuance as to why. We'll talk about that in the future, but just know for now, static methods are not overridden. If a static method defined in the superclass, if it is redefined in the subclass, the method defined in the superclass is hidden. It feels the same, but it's not quite, and there's some small nuances. We'll talk about that more in the future. An important slide here about overloading versus overriding. So now we have this new concept, overriding, and students sometimes draw parallels. Wait, is that like overloading? What is that? What's the distinction? So look here on the left of your screen. This is overriding. This is what we're talking about right now. What is overriding? We have here three classes: class test, class B, and class A. We see that class test has a main method. Inside this main method, we make an object of type A. So let's go down and look at object A and B. We see that A extends B. So let's back up and look at B. Class B has a singular method inside. It's a void method, and the method is called P. And that method receives a singular parameter, a double. And what do we do with that method? We merely print that parameter times 2. Pretty straightforward. Class A extends B, which means it inherits any and all public data members and public methods. So class A is going to, in fact, inherit this method P from class B. But notice what we do right here. Inside class A, we have a method called P with double as a parameter. That's the exact same signature. This is an example of overriding. Class A inherited from class B this method right here, but then class A said, you know what? That method we inherited called method P with a double parameter, I don't like it. I want to make my own version. So class A made its own version of that. It effectively casted aside the one that was inherited right here, and it made its own version. What does its own version do? It simply prints I. So we come back here to our main. We have an object of type A. When we say A.P, even though you see two methods down here, in fact, object A only has one method P, and it's this method P. Why? One more time. This one was inherited, but then we immediately overruled it using method overriding. We overruled it, we got rid of this method, and we made our own. So when I say A.P, I'm always calling this method right here. I send over 10, which is an integer. That can fit inside a double, and it will print 10.0. Here I send over 10.0, it comes here, and it prints 10.0. Compare and contrast that to the right side of your screen, where now everything all the way down to right here is identical. Everything's the same. The only difference is, now notice, when class A extends class B, inherits from class B, notice the name and the signature of this method. Here we have public void P int I. So class A inherits this method P with this same signature, where this method P has a double as a parameter. And then in our class A, we say, well, let's also make a method P with an integer as a parameter. So this was not overriding. We did not inherit this method from the parent and then throw it to the side and make our own, because the method that we chose to make has an integer as the data type of the parameter. Therefore, those are two different methods, two different signatures. That's not method overriding. In fact, this is method overloading that we've seen previously, where you have multiple methods, same name, different signature. Now we're officially at this super keyword. A subclass, we said, inherits all accessible data members and methods from the superclass. We know that. And we previously introduced the keyword this. What does that keyword this do? It refers to the calling object. Well, Java also has this keyword super. What does that keyword super do? It refers to the parent class. It refers to that superclass of the class in which the keyword super appears. And we can use that keyword super in one of two ways. We can either use it to invoke a superclass constructor, which is what's happening right here. We're invoking the superclass constructor, or we can use the keyword super to explicitly invoke a superclass method. And we're going to cover both of those. First, a question. Are constructors inherited by the subclass? And the answer is no. Constructors are not inherited. How, therefore, do we invoke a constructor of our parent? If you have a child class that has just inherited or is extending and inheriting from and extending a parent class, how do we invoke that parent constructor? The answer is by using the keyword super. If the parent has a no argument constructor, we would use the keyword super with no parameters. This will call that parent no argument constructor. Or if our parent has a constructor with multiple parameters, we would use the keyword super with a pair of parentheses, and we would send over all of those parameters. When we call this parent constructor, this superclass constructor, we can either invoke it explicitly, again, this is what we're doing here, or we could invoke it implicitly. So I'm going to come back to this explanation, and I figure it's now a good time to look at what's actually occurring here in this slide. We're really doing what's going on with this upper component, the top half of this slide. When we invoke a constructor of the superclass explicitly, what we do is inside a given constructor, in this case student, notice I sent over 4 parameters. 2 of them strictly belong to this student class, but 2 of them belong to the person class, the class from which student is inheriting, or the class that student is extending. So how do we assign this first name parameter, formal parameter, to the first name variable of the data member of that person class, or the same thing for this last name parameter? We do so by invoking the constructor of our superclass, of our parent. That's what's going on here, and that is what is going on here. So we sent over 12 parameters. Again, the final 2 were hours earned and GPA, which we assigned directly into their data members here. But what about those first 10 parameters? How can we save ID into ID? I can't say this.id equals ID. I can't do that, because put your mouse here, it says that ID has private access inside person, right? ID is private. Come up here, we see ID is in fact private. So by virtue of student extending person, student does have an ID, But how do we access it? I can't say this.id equals ID. I could, if I wanted to, I could say get ID, not get ID, sorry, set ID. I could say set ID equals ID. Take this parameter ID and use the setter ID, which was inherited, and set the ID number. That would work. Because if you come here and you look, you say, well, where is that set ID? I don't see it. Set ID is a setter that comes from our parent class. It's right here, set ID. So we could have chosen to use set ID. I could do the same thing, set first name, and Java understands that it can tell that you want the first name. I could say set last name, do the same. I could do this for each one of these parameters. Set email, done, email, set phone, and so on. I could have done that. But instead, I don't want to type 10 lines. Instead, I just do what? I invoke the constructor of the superclass, of the person class. I invoke that constructor. Here's this constructor right here. It's expecting 10 parameters. So what did I do here? In the constructor of student, the very first thing I did is I said, let's call that constructor of our person class. And we send over those 10 parameters, and boom. We come right here to the constructor of person, and we assign or we save those first five formal parameters. We save them into those data members, and then the next 5 parameters we send over to the address object, its constructor, to then save those accordingly. A lot of stuff working together. Super, super cool. So to understand, when you're constructing this student object, you are in fact almost constructing in parallel this person, because a student is a person, which we showed you last time. That is a relationship. A student is a person, so we have access to that person constructor, which is what's going on there. That's how you explicitly use the super keyword. We're explicitly typing it right here, and we're explicitly invoking the constructor of the parent class, of the superclass. Now, what if we don't explicitly use the super keyword? How is that super constructor invoked implicitly? Because I said it here, underlining it. We can invoke the constructor of the superclass explicitly or implicitly. How do we do it implicitly? If the keyword super is not explicitly typed, the superclass's no argument constructor is automatically invoked implicitly. That's the idea of what happens. So a constructor here, if I have public A, this is equivalent to public A and putting super inside. Or if I come back over to here, let's see what be another example. Remember, this student is extending person. Here I'm explicitly calling the person constructor that expects 10 parameters. What about on this constructor of student? Clearly, it's going to also construct a person, right, in parallel. So I could have, if I wanted to, I could have explicitly typed super with no parameters. And what's this doing? This will call the no argument default constructor of the superclass person right here. I could have explicitly typed this. This would be an explicit invocation to super, right? To the no arg constructor of person. That's what would have happened. That's an explicit invocation. I don't need to do that because Java does it automatically. If you don't have any usage of the keyword super inside a constructor, if you don't have it explicitly typed, Java automatically does that for you. So I'm gonna type this. The following is done automatically. In which case I can just comment it out. It's not even needed. That's the idea. So these are equivalent and these are equivalent. Important to know as a point of caution, if you choose to explicitly invoke a constructor, that explicit call to the constructor must be the first line of code inside your class, inside your constructor. So here, I've chosen to explicitly invoke the constructor of person. Notice it's the very first line of code inside this constructor of student. If I were to put it right here, you get an error. What does the error say? It's one of the more clearer errors. What does it say? The call to super must be the first statement in the constructor. Wouldn't we love if every error was that clear? The call to super must be the first line. So you must make that as the first line right there. Very important point. You cannot invoke the superclass's constructor name directly. So what if you're thinking, okay, I want to invoke the constructor of person, right? That's what's going on here. I want to invoke the person constructor. You might think, why can't I just do that? Let me just type in the name of the class and say here, hey, I'm invoking the person constructor. It just doesn't work that way. You have to type the word super instead. So I say, now let's go code up. We already have all this coded. We've explained it. I'm at 25 minutes. What we want to do is just look at these 3 bullet points here. Bullet point 1, first understand the usage of the word super in the constructor of person and employee. Let's understand that usage of the word super perfectly. Have we already done that? Have we done so? Maybe pause the video. Do we understand what's going on right here in student? Do we understand what's going on right here inside employee? That the very first line of code of employee inside the constructor, what am I doing? I'm taking those first 10 formal parameters right here. I'm taking them and I'm forwarding them over to where? To the constructor of our parent, which is super, which is person. So we're calling the super constructor, which is the constructor of our superclass, which is person. I'm sending over those 10 parameters and I'm saving them. I think we've covered that pretty exhaustively. What comes next? Let's make custom toString methods for person and for employee. What do I mean by that? Well, right now, as you notice, when I come over here to our main, let me get rid of this, and I run this code, even though Captain Marvel is just a person, and Black Widow is a student, and Cap is an employee, even though that's the case, you look at their output, it's all the same. It's okay for Carol Danvers because Carol Danvers here, Captain Marvel, was just a person. There's no salary to print because Carol Danvers was not an employee. There's no GPA to print or hours earned to print because Carol Danvers was not a student. But Black Widow is a student. And notice we don't have any GPA being printed. We don't have any hours earned being printed. What's actually being printed right here when we print S? As I told you, by default, it's calling the toString. Well, which toString? It's calling the one that's currently inside that student class. Well, what toString is inside the student class? Is it the toString that belongs to object? Well, you can see it's not because this is not hot trash, which it would have otherwise been. What is getting printed here? Remember, student extends person. Student is inheriting all of the public getters and setters and methods, including this toString right here. So what's being printed when we print s.toString of this student object, what is being printed is the inherited toString method that comes from person. One more time, because student is in fact extending person, so it inherited this toString method from person, and that is what is ultimately being invoked right here. And again, you don't need to even type toString, it's automatically called. So what we want to do is, as in the same way that the person object inherited, or the person class inherited from object, which means it inherited a toString method which was trash, and we then overrode it and made our own. Well, in that same way, this student class, we've inherited the toString method from person, and it's not trash. It's a good toString method, right? This right here is a solid toString method. But we don't want to use only that toString method. We also want to be able to do what? We want to print the GPA, and we want to print the hours earned. So we want to make our own toString method. So let's do that. Public string toString, string s equals an empty string, and then finally return s. So now, as usual, NetBeans is saying, hey, add the annotate or the override annotation to indicate that you are in fact making our own toString method for this student class. So here, we are making our own toString method and not directly using the toString method from the toString method inherited from the person class. This is the idea. So what do we want this? Imagine this right here is the student. This is Natalia Romanova. This is Black Widow. What do we want to print for this student object? Well, really, I want to print all of the same information, and then below it, I would like to print hours earned, and I would also then like to print the GPA. So as a starting point to make that happen, I'm going to just kind of, I don't know if it's going to help or not. I'm going to come over here to the person class, and I'm going to actually just highlight all of this, even the override annotation, and I'm going to copy it. I'm going to come over here. I'm going to highlight all of this, and I'm going to paste. I'm going to get all kinds of errors, no problem. What are the errors? Well, before I address the errors, I want to come to, because remember, I want to print all of that same stuff. I'm not even going to address the errors yet. I want to print all that same stuff, which is all of this, or not print, I want to concatenate to a string all that same stuff. And then afterwards, what do I want to concatenate? The hours earned and the GPA. So I'm going to highlight any one of these lines, this last one, and I'm going to say, now let's add the student-specific information, which is going to be here. This has to be hours earned. It's a little bit spaced over too much. I'm not going to go change the alignment. Hours earned. You know what? I'm going to change the alignment. I'm going to change it. Which means, let me go copy this back, those 6 concatenations. I'm going to copy that back over here so it can be consistent. Because I haven't changed it other than the spacing. Okay, that's good. So hours earned. So this should be, just type in hours earned. And then, of course, the next line of code needs to be what? The GPA. And this will be GPA. I'm going to space this over. And, of course, the GPA is a float, so this is going to be 0.2f. And this will simply be GPA. All right. So now we have those last 2 pieces of information printing that are student-specific pieces of information. How do we print this stuff? How do we print the ID, first name, last name? Well, we could use the getters. I could say get ID, right? Those are publicly accessible methods to us because we inherited them. This get ID, I'm inside the student class, and I'm calling the get ID method, which was inherited, which is going to print for me the ID. Perfect, or concatenate the ID. I could do the same thing, get first name. Same thing, get last name. Where did my output go? Get last name. I'm going to click this button, get my output back. I could do that for each one of these, and that would work. Well, except would work not quite for this. I'd have to get the address. It'd be convoluted. Let me just finish it for kicks. Let me get email, and then get phone. I think all of you would be following along. You should have typed all of that. Here, how do I concatenate the components of address? I can't just type a.toString. A does not exist. But if I get a first, so if I type get a, that will get me the reference of the object, the address object, and from that reference, I can then call it toString. So now let me just check what happens when I run this. Check this out. That now the spacing is off because I need to go change my address. Let me change the address spacing. 1, 2, 1, 2, 1, 2 for the alignment that we added. I think you follow. So check it out. Here's Carol Danvers, and here is Black Widow, right? I used in the student object, I simply had to change how I was accessing these values because I could not access ID. ID is a private data member. It's private data member in person, but I have the get ID, which allows me to access that. Hopefully that makes sense. Understand what's going on, how I accessed all of those values that were inherited from the parent. I had to access them via the public accessor methods, the public getter methods. And then finally, I concatenated the student-specific information. This worked, but let me show you what's now super cool. So here, I've made that toString method for person, but now inside this custom toString method of person, what am I going to do? I'm going to actually invoke the toString of the parent. So instead of doing all of this right here, I want to do something that is much better, much cooler. Remember, what I said is I want to invoke, I can't spell, invoke the toString method of the superclass of person. Because we have, that's really what all this is doing right here, right? All of those lines of code, that's really this stuff, right? That's really this stuff. In fact, I copied those lines of code, I pasted it, but instead of putting here first name, right? We had first name. Instead of putting first name, which was not accessible, it has private access, I typed get first name. So these lines of code are identical to what you see here, except the way that we're accessing those data members. Here we access them directly. Here we access them via the inherited public accessor methods, the getter methods. So since that's the exact same thing, wouldn't it be cool if I could just do this? Get ready. S plus equals, maybe pause the video. See if you think of how you would do it. That's awesome. This line of code is doing all of this, which I'm about to delete. This line of code is doing what? Anytime you type super, what happens? I'm going to come back to right here. It said that super can be used to call a superclass constructor, which we've already shown. We've done that. Super can also be used to call a superclass method. And that's what's going on. We're using super to call a superclass method. So here, when I type super, I'm going to the person class. And then when I type toString, I'm saying, well, go to that person's class, go to that person class and invoke the toString method, which does what? It does all of this. It makes a string, it concatenates all of this stuff, and it returns that string. Ultimately, that string that gets returned is right here. This is the returned string, which then gets concatenated onto this string. So how cool is that? That all of this right here, we can get rid of it now because we're really just going to invoke the toString method of the superclass, take that string that's returned, concatenate it onto this initially empty string, and then finally concatenate those last two student-specific pieces of information. And this is what we get. Natalia Romanova, Black Widow, here is all of their information. So now that we've done this once, it should be a little bit easier to do for employee. I can come to employee. I could have copy pasted. Maybe it's worth the time to actually code it. So public string toString. Of course, NetBeans is going to ask me to put the override annotation. And then here, string s equals an empty string. Return string, return s, which is what I do automatically every time. What is the very first thing that goes in here? Just s plus equals super.toString. Done. And now we're going to add the two pieces of employee-specific information. And yes, to save time, I'll come back to student. I'm going to copy this right here. In fact, I'll copy all of those lines of code, come to employee, and I paste. And let me get rid of, I should have really done this and then pasted so I don't have two calls to the super. And now I'm going to print here title title, the job title. I could have called it job title. Maybe that's better. Let's do that. Job title. And this will, of course, be title. And then salary. Let's make sure the alignment's good. Salary is, let's make it a float. Salary, of course, we need to make a $sign here. So dollar sign. There we go. And we return that. Let's now come and run this and see what we get. Cap, making 500,000 like a G. And here's all of his information. Cap's information. Super cool what we just did. Super cool that we now understand what's going on with not only overriding, not only inheriting and overriding, but the fact that we're understanding super, we're using super automatically. Here, super is, that's an implicit call to super. I don't need to make it. It's done implicitly. I could have typed it explicitly here. No need to though. We've done that. We've made these overridden two-string methods, but the coolest part is what we just did, where we made this overridden two-string method, but in addition, we then within that overridden two-string method, we said, because what we're really saying here is, hey, person, I appreciate you. I see that you have this two-string method. You did a lot better than the trash one from object, but still, it's not quite what I want. I'm going to make my own. Thank you so much. Appreciate you, person, but I'm going to make my own. But then you say, oh, wait, you know what, person? Actually, I kind of like part of your two-string solution. So we call that two-string method. We use its string that it returns, and then we simply add it on the student-specific and then the employee-specific information. Super, super, super cool. Now we're really in the gist of it with OOP. It's been fun. That's a lot to process. I'm just over 40 minutes. As always, reach out, ask questions if you have any. We're going to pick up next time right here with constructor chaining, but we will leave that for next time. It's been fun. Reach out if you have any questions. Take care, everyone.